Hey guys, so we did an intro to software engineering, giving you a brief metaphorical view of how we can design, how softwares are designed, the complexity involved. So today we are going to jump in programming, and I'm expecting that you have some preliminary knowledge and understanding of programming concepts such as data types, such as loops, conditions, constructs, functions, returns, print statements, and later on we're going to jump into some advanced concepts. Okay, so now just imagine that you're given a list of values and number of values you have, right? 1 2 3 4 5 and number of values. It's very hard for me to write it here, like I can write like 3 4 5 and so on. Right? So you want to find the function gets the list as an input, and you want to find a value, a specific value within this list. Then of course you have to iterate through the list to find the value, right? So what happens is you have your function, right? So so the way drawing is a very good way to understand the iteration of the program, right? So this is your function. In Python you write define, find value. This is your function. So now we go inside the function, right? So when we go inside the function, we have to iterate, right? So we have to have a for loop. I'm gonna signify it by this. It's your for loop. So you are now inside the for loop. You came. The compiler enters here. Reads it's a function. You call this function, correct? It enters here, comes to the for loop, and then inside for loop will have its own block, right? So this is block of the for loop, and then you see how it's logical, right? And then inside the for loop we will have this. In this block we will have, so basically this is inside the function, right? This for loop is inside the function, and then inside here we will have our if condition. We'll say if this value in this specific index that we are iterating is equal to my value which I want to find, then, so let's signify that by a diamond sign. This is our if condition. If it is there, then return the value. If it's not there, then what's going to happen is, if it's there, this if condition will return the value, right? And if it's not there, what's going to happen is this if condition, right? This is internal block. This will go back, give the control to the for loop, and this keep iterating, right? And if it's not find, the function, this is one route of it, right? For loop, its block, its if condition, and then return value if yes and no. Now the second thing is, if this was not there, then what's going to happen is you can have more lines within this function, right? So the next will be any kind of logic. If from here we didn't get a return value, then you might return something here, you might print something, you might just go ahead and apply other logics that you want, right? I can have as much logic. If we couldn't find it, we might just go ahead and call a sorting algorithm. We might just go ahead and do some other sort of operations, right? Or we might just say return false. So whoever is calling that function, they're going to say, well, if I get a false, this is how you build the logic. If I get a false value, that I'm assured, you make this hypothesis, and I'm assured that, okay, the function didn't find the value. That's how you build the hypothesis. Beforehand, you think like, okay, if this is an array, if I find the value, this condition will be true. This whole line will give me a true value. You see, you initiate a for loop, you come to the block of for loop, you have if condition in that for loop, it will return a value. If this didn't happen, then for surely it means that now we are here. Here you can return a value. You can say return false. You can return a boolean false, right? And that's how the software, the function will implement. Now if you follow this procedure, you can easily write the function, right? In the next video we will think about binary search and how we can optimize this, because this function is now running in order of n time. Why? Because if you draw a graph, right, you draw a graph, this is the input, this is the time, right? So the more the input increases, we know if there are n number of values, the time will keep increasing. You see? So it's going to take us order of n number, n. We don't understand, we don't know what is the total number of elements that we are getting. It may be million, billion, 1, 2, 3, a lot of things, right? So this is the fundamental concepts in here. So now you see how we can further, as I mentioned before, $100 function, right? You can write a very primitive function, you can write a very good function. We have to understand the edge cases, right? So for example, here we went directly to the loop. Well, what if somebody passes a list in here which has no elements? So again, what happens is even before for loop, we can put a condition in here and say if the length of the list is 0, the length of the list is 0, what we're going to do is we're going to still return false. Here we are also going to return false, right? We can put another else if condition in here, and we can say, I'm going to draw this like here. We can say else if. We can say if this is true, return false. Else if there is only one element, just imagine that there is only one element in here, then you don't even have to go to that for loop. You know, you prune this whole code, and then you say if there is only one element, check if it's equal to the value that my function wants. If it's equal to that value that I want to find, then return that value then return that value. That's it. So here you also want to return another value. You see, this is how you optimize code, and this is how softwares work. You also understood the algorithm complexity in here, right? And that's all. Thank you so much. In the next video we'll do binary search.